welcome to the School of Forest Resources and within the College of the Environment. We're in our 10th month of a new birth in pulling a group of different departments and schools together. And I think that if I looked at the list of people that are attending today and the diversity of topics that they're interested in, I think that's a perfect reflection of the sort of broadening of all of our visions. So welcome. I just want to very quickly frame a number of issues that I think will be covered in today's series of papers. And I've used this particular slide as sort of as a way of illustrating sort of, I think, maybe a value or a vision that many of us have for the Puget Sound region. From the water, in essence, to from the white caps to the white tops, this is a special place on the globe. And I think many of us see value in retaining certain elements of that place and understanding the pressure that those elements may be coming under and what we might do in terms of solutions. And we come at this from a whole range of perspectives, and I think that range of perspectives make for a very healthy discussion. So today's talk will be outlined around a number of themes. Three first talks will talk about the problem, and then the next sort of two sets of three talks are from a range of different perspectives, and they deal with those perspectives and solutions to the problems that have been outlined. So I think the context in which this discussion is thinking in terms of healthy forests and healthy forest landscapes, and the definition of health spans from the ecological to the social and economic. And this is a picture of a spruce budworm devoured grand fir on the east side of the Cascades, and even though we're just dealing with the west side, I think the forest health issues span. We're also thinking about the goods and services that forested systems provide, whether those are cultural or spiritual or recreational services, or are they monetary services. We're thinking about the broad suite that these things provide, and so there's a universal sense that the services that they provide have more value than, say, a shopping center. Let's just sort of frame it in that way. And then hopefully that gets reflected in the water quality, air quality, the quality of life that is in this particular state. So thinking of healthy people, thinking then in terms of these things, in terms of climate change and the impact that climate change may have on these systems, and even on what's now been termed climate refugees, so people from other parts of the world that might see the stability we have in the Pacific Northwest as a place to migrate to or immigrate to. Population increases in the area. And then I would also like to recognize the Denman Endowment for making these conversations possible and important. So one other sort of contextual thing is sort of the idea of reference points. So where do we, in our discussion of a system, whether it's an ecological system or a human system, what point do we use as a reference frame? And so here's an old-growth forest. Might have been a vision that people had in 1928 of this old-growth forest. And then, if you grew up in the 1990s, this might be your view of what an old-growth forest looks like. It's already changing in scope, but now this becomes our new reference point or our new baseline. And then as we continue in 2028, this may become our reference point. So the point is that in thinking about recovering systems or monitoring systems, you need these kinds of reference points to come back to. So we're going to explore this, and I welcome your participation and comments as we move forward. Thank you very much.
And the first speaker in this session is Bob Bilby. He's the Chief Environmental Scientist for Weyerhaeuser Company, and from 1998 to 2000, he actually managed the Watershed Processes Program at the National Marine Fisheries Service, Northwest Fisheries Science Center in Seattle. And today he's going to talk about the potential for private forests to contribute to the health of Puget Sound. Bob.
Really, this is the clumsy title. What I'm going to talk about today is better summarized by this first slide. I do want to talk about forest practices in Washington State, particularly how they've changed over the last 40 years. But what I really want to focus on today really is what I view as the most insidious problem, if you will, impacting forest lands, privately owned forest lands in Washington State. And that is the rate at which they're being converted to other land uses. And I'll talk a little bit about what some of the ecological consequences are of that conversion. And then finally, I will very briefly talk about what some possible, if not solutions, some possible mechanisms that we might employ to help reduce the impact of conversion on forest lands, ultimately on Puget Sound. Give you a little historical context on forest practices. Prior to 1970, we essentially didn't have any environmental protections incorporated into the forest practice regulations in Washington State, in Oregon, any place in the Pacific Northwest. There were several drivers that occurred in the early 1970s and through to about 1980 that really were the primary impetus for the development, the incorporation of environmental standards, environmental measures into the forest practice regulations in this state. A couple of them were the big environmental initiatives that were passed by Congress in the 1970s, the Endangered Species Act, the Clean Water Act. But equally, if not more important in Washington State, was the Bolt decision, which gave the right, that actually established that that tribes have the right to harvest a share of the fish in Washington State, and in addition, and probably more significant from the standpoint of forest management, they have the right to expect the habitat to be maintained in a condition so that they have fish to harvest. So the tribes at that time became major players in forest practices in Washington State. Also, through time, we in the scientific community believe that we've improved our understanding about how aquatic systems interact with the surrounding terrestrial environment. As that understanding has improved, we've been able to incorporate new measures into forest practices to address some of the deficiencies that we've identified. But essentially, the model that we've developed for protecting particularly aquatic systems on forest land in Washington State is based on one overarching principle. And that is that if we can accurately identify those specific locations on the landscape that are most ecologically significant, are most sensitive to the application of forest management measures, we can then achieve a very high level of environmental performance and still allow the landowner to grow and harvest timber on a majority of their ownership. That's the model that all of the forest practice regulations have followed over the last 40 years. First incorporation of an environmental measure into forest practices occurred in about 1977 here in Washington State. At that time, they focused on only one impact, water temperature. And as they required, as a result of this first go-around of forest practice rules, buffers to be retained on some streams. Streams that supported fish and that were, I think, less than 1,800 to 2,000 feet in elevation. These were considered to be the streams that were thermally sensitive. However, there was an exemption. If there was a risk of blowdown, you didn't have to leave a buffer. So functionally, there were essentially no buffers left on streams until the mid-1980s. A process was initiated in the mid-1980s called Timber, Fish, and Wildlife. And it was an attempt to negotiate forest practice rules and regulations with all the stakeholders in the room. Timber landowners, state agencies, the tribes, environmental groups. And as a result of this negotiation, the rules, the environmental protections and forest practices were expanded fairly dramatically. For the first time, buffers were required on all fish-bearing streams. That was, yes, to protect water temperature, but at this time we'd come to understand that large pieces of wood in stream channels were also critically important to maintaining habitat quality in streams. They form pools, they provide cover for fish. They are fundamentally important in regulating movement of sediment, organic matter, and nutrients downstream, so they play a key role in determining the productivity of aquatic systems. So the buffers were there both to provide shade, protect water temperature, but they were also there to provide a long-term source of large wood to these channels. The next big evolution in forest practice regulations in the state came in the early to mid-1990s, and it was a process called watershed analysis. Now, watershed analysis made the bold leap of saying, well, you know what, there's a lot of variable conditions around the state. So one size can't fit all. We can't use the same regulation everywhere. Let's develop a different package of regulations for each watershed in the state, which theoretically, scientifically, might be a good idea. Administratively, in terms of implementing, it was a nightmare. But what did come out of watershed analysis was some really good ideas and further extension of the protections offered under the forest practice rules. For the first time, landslide risk associated with road building and timber harvest was explicitly acknowledged, and prescriptions or protocols were developed to address that problem. And erosion of road surfaces and road ditches for the first time was highlighted, and rules were developed to try and help minimize the delivery of sediment from roads into streams. The last major go-round on forest practice regulations in the state was a process called Forest and Fish, which occurred from about the mid-1990s, late 1990s, through about 2001. One thing that Forest and Fish did is it took those good parts out of watershed analysis and incorporated those directly into the statewide regulations. So the pieces about watershed analysis, the pieces developed under watershed analysis for landslides, for road surface erosion, were explicitly incorporated into the statewide regulations. Another big change under Forest and Fish was an expansion in the buffering system. And the buffers were expanded not only laterally, they're not only wider, but really the big change was they were expanded much further upstream in the drainage networks. Two reasons for this. One, we'd come to appreciate that fish were actually living in streams far smaller than we'd ever believed possible. So now we actually require people to check and put buffers on everything that actually does support fish. The other change was that for the first time with Forest and Fish, there was a requirement to provide buffers on non-fish-bearing streams, all streams that flowed perennially. And you can see in this lower photo an example of an area that was harvested prior to Forest and Fish with no buffer on this small stream, and then an area that was harvested post-Forest and Fish with the retention of that buffer. A couple other changes with Forest and Fish was for the first time, floodplains were recognized as a sensitive part of the landscape, and some requirements were developed for floodplain or channel migration zones, as it's called in the rules. And then finally, there was a firm commitment and a timeline established for landowners to address problems associated with their road systems and to correct them. So things have changed over time. The critical question is, does it work? Is it effective? Quite frankly, we don't have the full answer to this. We do know that there has been some beneficial effects on water quality, particularly temperature and sediment. I'll show an example of that in just a second. What we don't know is what the biological impact has been of the implementation of these rules over time. We hope they're good for salmon. In effect, salmon and aquatic biota was one of the main targets of the development of these rules. But it remains uncertain how these critters are actually responding to the protections that have been designed to make things better for them. Part of the reason for that is the data that we have on these biological attributes of these aquatic systems is actually quite poor, and that's true even for salmon. A long-term record is really required to adequately assess whether or not things work. Very few of those are available. I will say one thing about the process that's been developed in Washington, and that is since the Timber Fish and Wildlife days, there has been an established scientific group who's charged with actually evaluating the effectiveness of the rules and then suggesting changes in those rules if deficiencies are identified. As I said, I'll show you an example from the water quality side. This is a very complicated graph, and I only want you to pay attention to the blue triangles, or diamonds. These are water quality data, and they've been collected continuously on the Deschutes River east of Olympia since 1975. These are sediment data shown in the blue triangles. It's actually turbidity. Turbidity is a measure of water clarity. It provides an index of how much suspended sediment is in the water. And you'll notice early on in the 1970s and 1980s, median monthly turbidity values frequently were quite high, in excess of 6 NTUs, indicating relatively cloudy water. That gradually improved through the mid-1990s, and then as we got into 2000 to 2010, turbidity levels now in the Deschutes rarely exceed 2 NTUs. The primary reason for that is the entire road drainage system in that watershed was replumbed starting in 1990. Road drainage water was diverted away from streams and onto the forest floor. That water has a chance to infiltrate into the soil, leaving the sediment behind. So here's an indication, one indication that the things that we've implemented over the last 30 years have had some positive effects on water quality. But again, our understanding of biological response is still relatively rudimentary. As I said, what I view as the real big problem, environmental problem associated with privately owned timberland in Washington today is not how wide the buffers are or how we manage our road system. It's the fact that forest land, privately owned forest land, is disappearing rapidly. There's a study done here at the College of Forestry Resources back in the mid-2000s that looked at forest conversion. They determined between 1988 and 2004, 17% of the privately owned forest land in Washington state had been converted to other uses. fully 5% of that had been converted to urban land use. That equates to a conversion rate of about 1% per year. In fact, if you take a look at the counties surrounding Puget Sound, that conversion rate is about double, in excess of 2% a year. And this is a map that was in that report that simply shows those counties of greatest risk of conversion. Those are shown in red, or excuse me, these are watersheds. You can see all the red watersheds, the ones at high risk of conversion, are right around Puget Sound, not surprisingly. Why are we seeing forest conversion? The number one driver for forest conversion is population growth. If we take a look at population in King, Snohomish, and Skagit County over the last approximately 30 years, you can see that we've gone from 1.6 million in 1980. The 2009 estimate was 2.7 million. So that's 29 years and a population increase in those three counties of 70%. More people need more houses. More people need more transportation infrastructure. They need water. They need power. The place that's easiest to convert are forest lands, and that's what's happened. 10, 15, 20 years ago, timber companies that basically put a tree in the ground and then ended up delivering a 2x4 to a retail outlet were the ones that were the primary owners of timberland in the United States. In the last 9 to 10 years, industry timberland ownership has dropped by more than half. In this particular graph, it's gone from 58% in 1999 to 26% today. Most of that timberland has been bought by investment organizations, insurance companies, endowment funds, things like that. Many of those new timberland owners have a very different set of management objectives than timber industry. Timber industry had mills to feed. These organizations don't. They view their investment in timberland as part of a very broad portfolio, and they're interested in getting return. One way that they can get return in a very short period of time is identify pieces of that timberland that can be developed, breaking that off from the larger timberland holding, developing that and selling it. That's one of the reasons why we're seeing, I think, in some areas, increased conversion, in addition to the population increase. Well, a number of years ago, recognizing that this was happened, me and a colleague of mine, Lauren Villerin, decided to take a look at whether or not we could actually quantify changes in salmon population that were associated with conversion of forest land. And as I said before, salmon data is actually hard to come by, particularly salmon data that's collected consistently over a long period of time. But there is one source of data that does fit those criteria, and that is spawner data that's collected annually by the Washington Department of Fish and Wildlife. Every year they go out to a set of stream reaches, they count the number of spawning fish, and then they and they do it repeatedly over time. We found 84 sites where that was the case, and on those 84 sites, 12 of those 84 sites had undergone conversion to urban during that period for which we conducted the study. Of those sites, we found an 80% decline in the proportion of spawning fish that they supported, 80% reduction in the number of fish supported by those sites. We also found that there were a lot of sites that supported a lot of fish consistently, and other sites that supported relatively few fish. So not all places on the landscape are equal for salmon. So the next step is we asked ourselves a question, of those highly productive sites, how many of those are actually being impacted by conversion? Is it disproportionately focused on those highly productive sites? We've begun to do some work on this, very preliminary work, and I'm moving quickly because I'm running out of time, but this is a project we're doing in conjunction with some folks at the University of Washington, taking a look at development, future development, and how that corresponds to these very high productivity salmon reaches. We identified the high productivity salmon reaches using a technique called intrinsic potential, which essentially uses topographic information to identify stream reaches that have the right kind of characteristics to support high productivity. Overlaid that with this effort, this modeling effort for development, which essentially uses a land change, very highly detailed land change analysis coupled with an urban model, and projects through time what areas are likely to develop. But to move ahead quickly here, these are three figures showing how development is predicted to increase through time. 2005 with the red colors showing the areas red and black in development, progressing through 2029 into 2050. You see development moving out towards the foothills from the already developed areas, but also development up the major river valleys, the Snoqualmie and the Snoqualmie. We take a look at the high value salmon reaches in yellow here, again overlaid with these 2005 and 2050 development scenarios. What you see is those high productivity reaches are down low in the watersheds. They're not up on the federal forest lands. They tend to be relatively low in the watershed. It's exactly the areas where we have been developing and exactly the areas where future development is likely to occur. In fact, if you take a look at the proportion of those high productivity reaches that are currently bordered by urban land use, it's already close to 33%. And about only 45% of them now are currently bordered by forest. As we move forward based on our development projections, by 2050, we're going to have about 45% of those high productivity reaches in urban environments, only about 29% in forested environments. And based on what we know about how these fish seem to respond to developing environments, that doesn't bode very well for Coho salmon in Puget Sound unless we change the way that we're operating. There are a couple of opportunities, I think, available to us. One of them is essentially regulatory or zoning. We need to be much more willing to incorporate into our zoning decisions areas of high ecological value, identify where those sites are, and ensure that land use is compatible with maintaining the productivity of those sites or retained within those regions. Conversely, that means we're also going to be deliberately directing development to other parts of the landscape. We're going to be developing, I think, ideally, areas of relatively low ecological value or areas that are already so compromised by current and past land use that they're not likely to make a major contribution to ecological health in the region. Another potential element that may slow the conversion of forest land, however, is new revenue streams on forest land. Things have been tried, like sale of development rights, conservation easements, but increasingly there's interest in monetizing various kinds of ecosystem goods and services. Carbon sequestration is the one that's closest to reality, but wildlife habitat, clean water may also be elements that could be monetized. And finally, energy. Forest lands can play a role in green energy. They can be areas where wind farms could be sited, and also increasingly people are interested in biomass for energy. So there may be ways to help offset some of this impact conversion of forest lands by increasing the value of the land. So there are opportunities out there. We're currently not taking advantage of them very effectively. My points were relatively straightforward. I think with commercial forest lands, and there's a lot of controversy still about how commercial forest lands are managed, but it's indisputable that over the last 40 years there have been dramatic improvements in environmental protections on commercial forest lands. Some of the water quality data that's available clearly indicates that that is the fact. And I think because of that, and as we improve our management of commercial forest lands, they are capable of making a substantial contribution to retaining and restoring ecological health of the Puget Sound region. But because they're being developed so rapidly, particularly around Puget Sound, the role that they're going to be able to play will be ever diminishing unless we get a little bit more intelligent about how we direct future development. I think if we're going to adequately address future development, clearly development is going to occur, it's going to require some changes in the way we think, particularly about land use zoning. We need to be, as I said a few minutes ago, much more willing to identify sites that have high ecological significance and zone those differently than areas that have lower ecological significance, even if those ecologically significant areas exist in areas that have the right kind of infrastructure to suggest they'd be ideal for development. But basically what we're doing by doing that is throwing the bits and pieces away. Salmon like to live in the same kind of areas where we have been developing for the last 150 years, and for all intents and for all indications, where we will continue to develop unless we do something differently. And I think that there are some approaches, there are some avenues that we can take to help mitigate, reduce the impacts associated with development. But as I said, we really haven't taken advantage of these yet. Thanks.
Okay, our second speaker in this session is Pete Bisson, who's a watershed scientist at the Forest Service Pacific Northwest Research Station in Olympia, Washington. He worked as an aquatic biologist for Weyerhaeuser Company for 21 years prior to joining the Forest Service in 1995. He holds affiliate appointments at the University of Washington, Oregon State, and University of Idaho, and is currently vice chair of the Independent Science Review Panel for the Northwest Power and Conservation Council. Pete.
Okay, you all know this is what it looked like. In some places, it still looks a lot like this. This was timber harvest on federal lands in the late 1980s, early 1990s. It was clear that the forest was becoming increasingly fragmented, and there was a loss of interior old forest species. And so by the by the early 1990s, a series of lawsuits had basically caused the court system to enjoin timber harvest, many timber harvest sites on federal lands, and the club that was used to successfully enjoin these timber sales was the listing of the northern spotted owl and other interior forest species. So when President Clinton came to Portland in the mid-1990s to convene the Northwest Forest Summit, the emphasis was primarily on what can we do to bring back some sustainable level of harvest, but also to conserve the species that we are very worried about losing. And of course, one of those was fish. And in fact, if you had gone down to Portland during President Clinton's Forest Summit, you would have seen a number of the demonstrators out on the street wearing pins that said, "It's the fish, stupid," because at that time, really, that was a time when there was a wide recognition that salmon were becoming increasingly at risk, just as many of our other wildlife species were. And in fact, during the 1990s, there was a real surge of listings, such that by the early part of this last decade, 27 population segments had become of salmon had become listed coastwide, and these included 3 that are currently listed in Puget Sound: the Puget Sound steelhead, Puget Sound chinook, and Hood Canal summer chum, as well as Puget Sound coho, which is not currently listed but is classified as a species of concern. One of the things that the Northwest Forest Summit resulted in was the assembling of the Forest Ecosystem Management and Assessment Team, a group of scientists whose job it was to put together a landscape management plan that was based on science. And because there was a strong emphasis on water protection, largely for fish, the question came up, is what we're doing with regard to our current systems of streamside buffers enough to protect these organisms? And so the FEMAT scientists stood back and basically said, we know that the current system of buffers represents a compromise between the policy wishes of the fish and wildlife folks as well as the timber managers, and that the widths of the buffers was basically some intermediate value that's a little less than what the fish folks wanted and a little more than what the foresters wanted. Nevertheless, they said, well, let's just put all of that aside and ask the question, what are the ecological functions that we wish to conserve in the riparian areas? And they came up with these 2 sets of curves that define ecosystem functions along streams. And whether or not you agree with the accuracy of the lines in these curves, they still remain to this day somewhat contentious. No one can argue that they took riparian management to a different place. Riparian buffers stopped becoming just places to provide shade and sediment control and started becoming wildlife habitat, sources of large wood, sources of organic matter, and all the other things that riparian zones do. And it's probably telling that in the most recent iteration of the Record of Decision, the legal document that serves as the operating guide for federal agencies, spotted owls don't appear on the logo of the record, this particular version. It's salmon. And that's because really fish became one of the real cornerstones or centerpieces of where the federal agencies were going with their forest management. So that sort of led us to what was the second, led the Forest Service to what was the second major emphasis area in the wake of the Northwest Forest Plan, and that is habitat restoration. The Forest Service manages the largest road system in the United States with a budget that's woefully inadequate for the job, and we knew that we had many roads, forest roads, that were crumbling and seriously in need of repair and were contributing to poor water quality and all kinds of habitat problems downstream. So there was a large push to improve the conditions on forest roads, and not only required relocating roads that were built in places that they should not have built in, and improving drainage systems that were inadequate to control hill slope drainage, but also to replace road crossings that were either completely or blocking fish passage. So to this day, a substantial part of the Forest Service's operating budget for environmental protection goes towards road improvements, and I suspect that it's the same for many other public agencies. Roads continue to be one of our big problems. This is a culvert that's been replaced, that has replaced one that was blocking fish passage, and I think a lot of people don't realize how much one of these things costs. If you count the cost of all the paperwork associated with putting these things in, they're about $100,000 a piece. So it adds, and that's a lot of zeros, and it adds up quite quickly. Now, that sort of brings us to the next emphasis area, and that took place really in the early 2000s. There was a period of 2001 to 2004 that over the western U.S. it was basically drought conditions. I mean, by drought conditions, I mean significantly below average rainfall. And during that time, there were a series of very large, severe fires. There was along the Rocky Mountains, Southern California, here in the Pacific Northwest. And this raised all kinds of concerns about the way the Forest Service had been managing its forests over the years, and had we done things that actually contributed to the severity and extent of these large wildfires. If you look at the Forest Service culture, and this is a poster from the early 20th century. This is in the pre-Smokey Bear days. We have had a long history of viewing fire as this apocalyptic figure riding through the forest, trying to destroy our natural resources, when in fact forest fires actually do a lot of ecological good. And we hadn't been doing a very good job of managing our forests to be either compatible with or resilient to wildfires. So when, under the Bush administration, when the Healthy Forest Restoration Act was passed, the emphasis largely went from restoration, in many cases, of in-stream conditions to restorations of the hill slopes in such a way that they would be a little more resilient to these natural disturbances and also a little less prone to large wildfires. Now, here in the Puget Sound area, big wildfires are not necessarily the problem that they are on the east side of the Cascade Mountains or along the spine of the Rocky Mountains or in other parts of the U.S. But nevertheless, that whole, the whole idea of managing to improve forest health really swept through the agency in the early part of the last decade. And a lot of the budget went to thinning projects in other areas to reduce the accumulation of combustible material on the forest floor and to thin the forest in such a way that many of the smaller trees that would normally be killed by fires were removed before they could burn and spread ground fires up to the crowns of the larger trees. The fourth emphasis area really took hold in about the mid part of the last decade, and this is landscape planning. The agency had to step back and ask the question, well, okay, if we want healthier forests, how do we want them to look? And in order to answer that question, you have to stop asking the question at the site scale, and you have to back up and answer the question at a much larger scale. So there has been a lot of effort to develop a variety of landscape analysis tools to begin to forecast how the future could look given a variety of policy scenarios, and what are the alternatives should we wish to change our policies and implement some different directions. One of the examples of this was a project that was recently completed in Western Oregon called the Coastal Landscape Analysis and Modeling Study, or CLAMS, where a variety of natural resource conditions, public and private land, and state and private lands, were modeled over time to see how they could look given different policy directions. I just picked land development change because that's one of the themes of the conference this afternoon. but you can also do this for forest age and a whole variety of other natural resource conditions. So clams is an example of the kinds of perspectives that the agency is starting to look at much larger scales now. Here's Western Oregon. We're also doing these kinds of analyses in Western Washington. But to get down to how's this going to help the local forest ranger district, we have to take those landscape planning tools and begin to drill down a little deeper and ask, how can we apply these on the ground? And one of the most interesting and revolutionary approaches has been the Blue River Landscape Management Plan. Unfortunately, this isn't from the Puget Sound area. This is from the upper Mackenzie River in the Western Oregon Cascades. On the left-hand side, you'll see the Blue River watershed, and the dark lines represent the forest, the stream buffers that would be in place under the Northwest Forest Plan. And as many people have pointed out, this creates a largely unmanageable landscape consisting of a spaghetti-like network of forest reserves with a matrix in between where more intensive management can take place. Well, if you're a forester, this creates lots of problems from a logistical standpoint. So then, is there a better way to do it? And so working carefully with the local stakeholders, with the environmental community and others, the folks that developed the Blue River Landscape Management Plan said, well, what did it used to look like under conditions prior to Euro-American development? What kind of forest did we have there? And they identified areas that burned more frequently, areas that burned less frequently, areas with different kinds of disturbance regimes, and then basically made those into planning units that were much larger but allowed for management to continue right into the riparian buffers. Now, that meant that you could do some thinning in riparian zones next to streams, which did make some people nervous, and so there was a trust issue that had to be overcome before the landscape management plan could be implemented, and this is one of the first ones. Now, on the right-hand side, the darker areas represent longer rotation forest management, up to 200 years or more, with a few thinnings, commercial thinnings in between. The right-hand diagram actually results in a somewhat lower timber yield than the one on the left. On the right, I think the timber yield is down about 15%. However, the value of the wood produced under the scenario on the right, with longer rotation and larger trees during the thinnings, leads to more valuable wood and somewhat reduced operating costs. So although the two areas are about a wash with regard to how long, whether or not one is better than another, the one on the right will probably get us to forest conditions that are much more closely similar to what they were under historical regimes. The final area of emphasis has been climate change. That's the one that's come to affect the Forest Service nationwide. This is from the Climate Impacts Group here at the University of Washington. I think many of you are probably familiar with this graph. The one on the bottom shows a projection for precipitation. The graph on the top shows the projected increases in air temperature, both under two different scenarios, that one of which assumes continuation of current policies with regard to greenhouse gas emissions. The other assumes that there will be fairly aggressive conservation. But in any case, they're both going in the same way. The bottom line is precipitation is not projected to change greatly here in the Northwest, but it's going to be falling more as rain and less as snow, and of course it's going to get a lot warmer. What this means is that summer flows are going to be reduced. I just took some data from the USGS for about 50 years worth, beginning in the mid-1950s, and plotted them out over time. These are the average monthly discharges at Snoqualmie Falls. And remember, much of the area above Snoqualmie Falls is in roadless, largely wilderness area, so this is probably a legitimate signature of climate change. We're seeing a lot less water coming down. So the task for the agency then is to start asking the question, what kind of forest do we want that will act as better sponges to actually soak up that precipitation in the winter and release it more slowly in the summertime? And then finally, I'll talk about the issue of carbon sequestration. The Wilderness Society recently released a report just a couple months ago identifying the top 10 carbon-storing national forests in the United States. All 10 of them are here in the Pacific Northwest. And I think it's notable that 3 of those directly affect Puget Sound: the Olympic, the Gifford-Pinchot, and the Mount Baker Snoqualmie, all in the top 10. These are in metric tons of carbon per acre. Now, the Forest Service is aware of this and realizes that this has value now in this new age of carbon credits, and is going to be very anxious to hang on to these, to this particular resource value, and maybe even see it increase with time. So in summary, I've identified what have been 5 different emphasis areas that have basically been layered one on top of another over time since the Northwest Forest Plan. These aren't the only 5. I'm sure we're going to see more and more in the future, but this is sort of where we are now and is probably going to be, as I said, added to in the coming years. And I'll close with one thought. The Forest Service provides the drinking water for approximately 20% of the people in the United States. That is, that water flowing off Forest Service managed watersheds. Here in the Pacific Northwest, I suspect that percentage is a bit higher. And at least some studies have projected that the demand for drinking water could as much as double by 2040. That's going to put a tremendous amount of pressure on us as an agency to make sure that we do a good job of stewarding this water so that this supply of clean water is going to continue right along into the future. Thank you.
Okay, so the final talk in this session is by Peter Goldmark, who's the current elected Washington State Commissioner of Public Lands and manages the Washington State DNR. He chairs the State Board of Natural Resources and the State Forest Practices Board, and he's going to give us the Department of Natural Resources perspective. Peter.
Thank you very much, and good afternoon, everyone. I think the timing of my presentation today couldn't be better. I'd like to build on the remarks that have been made by my predecessors today, because I think it's clear that there are many things that we need to address to achieve the goal of improving the health and resilience of the Puget Sound. DNR has many responsibilities in this state, and many of its activities that it carries out have a direct impact on the Puget Sound. DNR is the state's regulator of timber harvest practices, and you have heard reference to forest regulations and their historical significance and the impact on riparian areas. In addition, DNR is the manager of the state's aquatic lands, and there are roughly 1.9 million acres of aquatic lands in the Puget Sound. DNR manages about 30% of the tidelands of the Puget Sound and is responsible for the entire bedlands of the Sound. In addition, DNR is the state's largest firefighting force and is responsible for putting out fires on both public and private lands, forested lands in particular, and partners with the Forest Service and many other municipalities to discharge that heavy responsibility. In addition, DNR is the state's land manager for all of the state's trust lands, which are about 2.6 or 2.9 million acres, which includes about 1.9 million acres of forested lands across the state. It's important to note that the revenue from these trust lands is used to support the trust beneficiaries, primarily K through 12 school construction, but also for school construction here at the University of Washington, WSU, other schools, and also provides an important income stream for counties that have forest on their lands. So we have multiple responsibilities, but today I want to focus on one of the activities that we're involved in, and that's forestry. How we carry out forestry on the state's trust lands. And to do that, I want to give you a little bit of a perspective Some of the previous speakers have talked about the transitions that we've gone through in terms of managing our riparian areas, and why we've done that, and what some of the results have been, and how those, hopefully, are contributing to the improving conditions of water that's being delivered to the Puget Sound. But I don't want to talk about the riparian areas alone. I want to talk about the forestry that's practiced on all of the forested lands in the state, and hopefully end with a positive note about where DNR is going and perhaps where the industry can go to help provide more solutions in the future. Now, this is a picture from the early 1900s, when logging really got going in earnest here in the state of Washington. And yes, it was very primitive. And yes, it was very labor intensive. And yes, the landscape was left more of a moonscape behind than it was a well-managed landscape. By the time the middle of the 1900s rolled around, there were some modest changes that were happening, but still there was no riparian protection, there was little or no habitat acknowledgement. You can see that this landscape, in all probability, contributed to the declining health of the Puget Sound. Indeed, even in the 50s, as has earlier been mentioned, there was no protection at all for riparian areas. And so when large rainfall events happened, or snow or rain on snow events on frozen soil were to happen, there would be the delivery of enormous amounts of sediment, woody material, and all kinds of material into streams and rivers, choking those waterways, and of course delivering a lot of that nasty material down into the Puget Sound. So forestry's had a troubled past. But it's important to understand that the function of forestry during that period of time was rather limited. Trees were harvested as a source of wood for heat and also as a source of wood for building materials. As has been mentioned earlier, there was no regard for the other multiple functions that's provided by our forested landscape. So today at DNR, we are embarking on providing more of the native forest function as we carry out our very important activities as generating revenue for the trust beneficiaries. In acknowledgement of that, we have adopted a habitat conservation plan, and that habitat conservation plan has different values in it that require us to manage the forest in a more holistic fashion. To begin with, we leave trees on the landscape, and we can leave those trees in either scattered or clumped conditions depending on the ecological functions that we hope these trees will carry out. Of course, by leaving trees, we're leaving the opportunity for habitat to be developed as the next succession of forest emerges, and these older stands can become more these older trees can become more complex and more functional for the many habitat functions that are required. So we're starting here in this set of photos to achieve a more multifunctional landscape while we're carrying out a revenue-producing activity. So this then is a little bit more of the same, where we have variable retention harvest with scattered leaf trees for multifunction. In addition, we can group our trees or leave them in specific ecological function by leaving them in corridors or in specific locations to achieve discrete habitat values. Now, I think it's important to acknowledge, although it's not shown in these slides, that at the same time, of course, we at DNR are leaving the maximum riparian buffers as required under forest and fish, because the important thing to realize here is that riparian function is very important, and salmon are very important. And that's the purpose of riparian buffers. But there are other functions, as we are talking about today, that need to be provided by the landscape to make sure that we are indeed doing more than just trying to protect the stream bank. We need to also store the water, as has been mentioned. We also need to filter out the water and to provide clean water to the stream or the river. And there's the shade issue, and there's also the upland habitat issue, which is something that DNR must confront. And that is, we have endangered species. Two of note are, of course, the spotted owl and the marbled murrelet. And each of those species, it's important to have complex older trees there to provide for the habitat for these species. So as we leave trees, we are carrying out multiple functions. And hopefully you can see that these are around habitat, they're around clean water, they're around carbon storage, they're around clean air, and other functions that we have not valued. But I think it's really important to understand that as we go through this transition of changing how we carry out the forestry, we must find ways to value these other deliverables that are present either in this landscape or in the next slide or in a succession of slides that I'm going to show you. Because today we've talked about conversion. And we know that conversion is occurring at a significant rate. And to prevent conversion, we must bring to the landowner more value so that there is less incentive to convert that forested landscape and more incentive to keep those lands in production. And not just for wood, but also for all the complex ecosystem services that we know are important, not only for today, but important for tomorrow. So just to mention a few of those, of course, for today, the first two benefits are given and not well valued today, I might point out. But also the habitat and the other functions are so important. So the forests of the future need to address a much more complex series of deliverables for DNR and for the people of the state, so that working lands are valued for their watershed function as well as for their wood production. That forest certification can be entwined in this to add value for value that is delivered across the landscape, that these lands can also deliver recreation, and as has been mentioned earlier, of course, carbon sequestration is an important ecosystem service that is beginning to be valued, but only just beginning. And lastly, forest biomass has been mentioned, and I'll mention that here in just a few minutes. So to come back to the major theme, this map delineates some of DNR managed lands within the Puget Sound watershed. I apologize here on the eastern slope, on the eastern margin, it didn't quite include the crest of the Cascades, and so misses quite a few of DNR managed lands in that landscape. But the point of the slide is that DNR managed lands are a very important component of the watershed of Puget Sound. And as we manage those lands, we can help provide some of the solution that we must find for the health and recovery of Puget Sound. Forest biomass has been mentioned earlier. It's one of the many other deliverables that has modest value now, and hopefully we will have more value for forest biomass in the future. DNR, under my leadership, has been interacting with the legislature and the Office of the Governor over the past 2 legislative sessions. We now have 4 pilot projects occurring across the state of Washington to convert waste biomass into different forms of energy, including heat and steam, also complex hydrocarbons for transportation use. So we're hopeful that those piles of flash that many of you have seen along forested roadsides and seen those burned as waste, those waste piles can now be chipped or somehow put into a deliverable form and converted to usable energy. This is a forest that has just been harvested, and hopefully this is one of the models that we can achieve more and more in the future. This has been mentioned under the Northwest Forest Plan as one of the goals of forestry for the future. If you start with a landscape that we saw in the earlier slide, and then you go to this landscape, you can see that we're doing a much better job. The yield in terms of commercial material, wood, off a landscape like this from a variable density thinning is, of course, much less than it would be if the whole area were clear-cut. But that's not the point. The point is that we can achieve many different outcomes by managing our forests in a way that produces important habitat for species, that produces clean air for everyone, that stores carbon, that produces clean water, that, as we've heard earlier today, stores water for discharge at a later time during the hot weather months. And yes, it does provide wood for both building and also for heat. But it also provides biomass for energy production, and who knows what else we'll be able to find of value in our forests. I think it's very important to recognize that forestry management plays an enormous role in the health of the Puget Sound, and that those of us who manage our state's precious natural resources are doing our best to be part of the future solution. Thank you.
Thank you.